So here we're going to be talking about dividing polynomials, which is basically going to be factoring and using laws of exponents. So the steps for dividing when we have a monomial, which just means one term on the bottom. So you can see on this first problem, we have one thing on the bottom, we have a polynomial on top, we have two terms on the top that's separated by addition and subtraction. That's what makes it have more than one term. Any addition or subtraction means there's more than one term. Here we have three terms divided by one term. A monomial on the top, on the bottom. Monomial on the bottom, and then actually it's a trinomial or a polynomial on the top. The steps are going to be basically just to split that top numerator up. We're going to split the numerator up by those terms and place each term goes over the denominator. Then we use the laws of exponents to simplify as much as we can. So I'm just going to take that one step at a time. I'm going to split up the numerator. I'm going to split this into two different terms. That one term, that's the second one. 8x to the fourth over, I'm going to place that over the denominator, 2x squared, minus, so that was this, minus this, over the same denominator, 2x squared over 2x squared. There's a minus sign in between because there was a minus sign in between to start out with. That sign stays the same. I'm really just splitting this into two separate fractions. I'm splitting it into one fraction from that and one fraction from that. Then I simplify those fractions separately. 8x to the fourth divided by 2x squared. I'm going to divide the coefficients. I divide these two numbers and I subtract the exponents. I divide 8 divided by 2 is 4, and I'm dividing 8x to the fourth divided by 2x squared. I'm going to subtract those exponents. That becomes x squared. 4 minus 2 gives me 2. Minus, anything divided by itself is just 1, and I can see that from dividing these two. That would give me 1. These completely cancel out. Really gives me x to the 0th power, which equals 1. So 2 divided by 1. 2 divided by 2 is basically just 1. So that's our final answer, 4x squared minus 1. The next one we're going to have three terms because there's three terms originally on the top. So I'm going to split this into three separate fractions. 8x to the 7th over 2x minus, that minus sign stays the same, 2x to the 3rd over 2x plus 2x over 2x. Just splitting the numerator up into three terms and keeping the denominator the same on all three of those. Now I follow the laws of exponents on each fraction. Eight divided by 2 is 4. X to the 7th divided by x to the 1st is x to the 6th. I'm subtracting those exponents. 2 divided by 2 is 1. I'm going to keep that minus sign in there, so that's going to become 1 x squared. Again, I'm subtracting those exponents. And then 2x divided by 2x, anything divided by itself is 1, and you have to write that. It doesn't just completely cancel out, it turns into a plus 1. That's as simple as that is. There are no like terms in there to combine. On letter C, it's the same thing. There's going to be three terms. 12x to the 5th times y minus 3x to the 10th times y to the 3rd plus 21x to the 15th times y to the 4th. Each of those gets its new denominator. But that didn't really change at all. It's still that same denominator, 3x to the 5th times y. Now we follow laws of exponents on each of those to figure out the new set of monomials. This, and this get divided separately. So that turns into 4. The exponents completely cancel out there. X to the 5th divided by x to the 5th is just 1. Y divided by y is just 1, so those cancel out. I really just end up doing 12 divided by 3 minus negative 3 divided by 3 is a negative 1. X to the 10th divided by x to the 5th. I'm subtracting those exponents. That's x to the 5th. And then I subtract exponents again. Y to the 3rd divided by y to the 1st becomes y to the 2nd. The last one, 21 divided by 3 is 7. And I subtract exponents again. That gives me x to the 10th and y to the 3rd. No like terms here, so that is my final answer. The next one is different. I really want you to compare those two. There's only one term on the top here. This is just laws of exponents. There's no addition or subtraction happening on the top. We're just going to follow laws of exponents. So I'm going to distribute this exponent first. That 2 gets distributed into all 3 of those pieces of that first part. 2 squared is 4. A to the 2nd raised to the 2nd power. We're multiplying those exponents, that becomes 4. And we multiply these exponents. 2 times 1 becomes 2. Still have multiplication in between here. And that's really important because these aren't like terms. This and this aren't really like terms, but I'm multiplying, so it doesn't really matter. I'm allowed to multiply those two together. 4 times 3 is 12. A to the 4th times a to the 1st is a to the 5th. B to the 2nd times b to the 3rd is b to the 5th. And there's no c from here, so I'm just going to leave that c alone. I'm going to write it as c to the 1st. It's all still divided by 4a, b, c, with exponents of 4, 8, and 2 respectively. Now I can divide that as just one term. I'm going to divide straight down 12 divided by 4 would give me 3. And for each of the exponents, I'm just going to subtract a to the 1st, that's 5 minus 4. 5 minus 8 is a negative 3. And 1 minus 2 is a negative 1. I cannot leave negative exponents in my answer, so I'm going to change this into a fraction still. Both of those parts still have a positive exponent. 3 is just 3 to the 1st, really. That's got a positive exponent. A to the 1st is also a positive exponent. The other two have negative exponents. Those are going to drop to the bottom of the fraction and switch to a positive exponent. You don't really need to write any of those ones. I just wanted to write that to show you that they all have to be positive, and really to distinguish between positive and negative exponents. The next one is talking about an area of a rectangular piece of carpet, and it's represented by that expression. That's the area. If the width of the carpet is 5n squared, what's the length? So the final area of any rectangle is just length times width. So they're saying the answer to this is 20n to the 4th minus 15n to the 3rd plus 35n squared, and that equals length times width. We don't know what the length is. What is the length? We don't know that yet, but we know that the width is 5n squared. So I'm basically solving an equation. I'm solving a multiplication, solving for, really, I'm trying to cancel out that multiplication. So I'm going to use division. That's really what we have to do on both sides. Divide by 5n squared there. Cancel that out. That would leave me with just the L on that side. And if I divide on this side by 5n squared, I also have to do it on this side. And we know when we divide, we're going to split this into 3 separate division products. So dividing each of those by 5n squared, that would give me 4n squared. I'm subtracting those exponents. Negative 3n plus 7. I divide each of these terms, and that leaves me with the length. this width times this length would equal that area. Alright, on the back, I'm going to have you try 3 of these try problems on your own. I actually will upload another video showing how to do each of those, but I definitely want to show you how C ends up working out. It's the same idea. We still split this into 3 separate fractions. So let's go with purple. 3 separate fractions, 16x 7y to the third over the denominator. I have my 3 separate fractions just like before. It's going to work out a little bit differently than before, though. So I'm following the same exponent rules. I'm dividing the coefficients and subtracting exponents. That would give me 4x to the 4th, y to the negative first, and minus 3x to the third. Nothing's really happening with that z. So that's going to stay the same. And I'm going to rewrite that y to the 4th on the bottom as a negative exponent. I don't really have to, but I'm going to just show that as a negative 4 for now. It's really like there's a y to the 0 on top, because that's just 1. I can put y to the 0 wherever I want, because that's just multiplying by 1. That doesn't really change anything. I'm subtracting those exponents. 0 minus 4 would give me a negative 4. Or you can think about exponents on the bottom of the fraction just representing negative exponents. And then I'm going to subtract the other exponents, and I'm going to divide these two. That's 2 divided by 4, that's 1/2. I'm subtracting the exponents for x's, those cancel out. Subtracting the exponents for the y's, those also cancel out. And that leaves me with z squared. The last step, I just have to cancel out those negative exponents. I'm not allowed to leave negative exponents in my answer, so I'm going to make fractions of the first two and kind of simplify that fraction also. I'm going to drop this y to the negative first to the bottom. So this becomes, I'm going to write it over here. Hopefully you guys have enough room. I'm going to write it on this side. 4x to the 4th over y to now the positive first power. Minus 3x to the 3rd z to the 5th over y to the 4th power. I needed to make fractions there so that I can deal with those negative exponents. I'm not allowed to leave a negative exponent, so I drop that to the bottom of the fraction and change it to a positive. I'm also going to simplify this. I'm going to bring that z squared up to the top and keep the 2 on the bottom. That is the simplest form that this can take. The next part of this note is dividing by a polynomial, which means there's more than one term on the bottom, and that's what you can see in both of these two. We have an addition or subtraction problem on the bottom of the fraction. That makes it a polynomial. There's more than one term. So I'm going to factor the numerator, and I'm going to factor the denominator if necessary. And then I'm going to divide or cancel out any common factors. So my first step is to factor the top as much as possible and factor the bottom if I need to. I don't have to factor the bottom on this. X plus 6 can't be factored. That's as simple as that gets. But the top can be factored. So my A is 1 here. That means I'm looking for something that's going to multiply to be negative 18. Multiplies to negative 18, and it's going to add up to a positive 3. That combination has to be a positive 6, and a negative 3. Those multiply to be negative 18, and they add to be a positive 3. That's how I'm going to factor my top polynomial. I'm going to split that into those two factors. That's x plus 6 and x minus 3, still being divided by x plus 6, which is really convenient because I have an x plus 6 on top and an x plus 6 on the bottom. Those are the common factors that I'm talking about here. The common factors are x plus 6 on the top and x plus 6 on the bottom. They completely cancel out. That leaves me just with this factor, x minus 3, and that is the simplified version of this original fraction. On the second one, I need to do a little bit more. The bottom can't be factored, so I'm going to leave that as 2x plus 1, but the top doesn't have an a that's 1, so I have to do the extra steps of factoring by grouping. So instead of just a, I have to use a times c, which here is going to be 24, and b is 11. So I'm looking for something now that multiplies to be 24 and adds up to be 11. That has to be an 8 and a 3. 8 and 3 add up to 11, and they multiply to be 24. So I'm going to split my middle term. That 11x is going to split into those two terms. This came from 11x. Now I'm going to do the grouping step of factoring by grouping. I'm going to group these two, and I'm going to group these two, and I'm going to take the greatest common factor out of the first two and factor this second set of parentheses so it looks exactly like whatever I get from this one. So I'm going to divide out 2x from each of those. That leaves me with 2x times 3x. 6 divided by 2 gives me 3. And I subtract the exponents, that gives me an exponent of 1 still. And then I cancel out these x's when I divide, and I do 8 divided by 2, that's 4. That's very convenient because that's exactly what we already have here. Common mistake is to not even write the factor that comes out of the 3x plus 4. I was thinking about the factor already. There's nothing that actually needs to come out of this to make it look identical to that, which means our second term in this factor, the second GCF, is really a 1. We can imagine dividing this by 1, dividing this by 1, and having that come out to the outside. So my two factors are 2x plus 1 and 3x plus 4. Still divided by 2x plus 1. It's not a coincidence that the denominator shows up in the top. These factors are going to cancel out, leaving us with 3x plus 4 as our answer. Hopefully you can see what's happening here. That cancels out, that cancels out. One of the factors should cancel out with whatever's on the bottom. Might not cancel out completely, but it should cancel out with some of the stuff on the bottom. Okay, the next one involves working backwards a little bit, thinking about this being multiplied times something. 1 plus 4xy times something to end up equaling the stuff on top. And I really just want to look at the second term. I'm thinking about this. Actually, I'm going to put this in parentheses, that's kind of important. This gets multiplied times something to give us that. So 4 is changing into 16. So this something has to have a 4 in it. To go from 4 using multiplication to get up to 16, I had to multiply by a 4 somewhere in. To go from x to the first to x to the third, I needed to multiply by x squared. And to go from just a y by itself to a y squared, I have to multiply by y. And hopefully it makes sense for this other term also. This 4x squared of y is coming from 1 times this something, which we just thought should be that. Actually, that is that division. That simplifies to that factor. Another way to do this is to think about factoring out the greatest common factor from here. It's not always going to work out perfectly, because if this doesn't involve the greatest common factor, you might need to factor out something else from the top. But if you factor out something from here, which happens to be 4x squared of y, you get 1 plus 4xy, all divided by 1 plus 4xy, and these completely cancel out, leaving us just with the greatest common factor. It happens to be the greatest common factor. It doesn't always happen to be the greatest common factor. Sometimes it's just anything that you can factor out to make these factors the same and cancel out. The last one here involves factoring the top and the bottom. The bottom actually can be factored. So if you forget how to factor this, it's one of our special cases, but if you forget how to actually factor that, you can imagine a 0x in the middle of this. And then think about what's going to multiply to be negative 16 and add up to be 0. So I'm going to do the top first. What's going to multiply to be 40 and add up to 14? That's got to be 10 and 4. I'm going to do the same exact logic for the bottom. I'm looking for something to multiply to be negative 16 and add up to 0. Basically just cancel each other out. So they have to be opposites of each other. That has to be a positive 4 and a negative 4. So my top factors into these two, x plus 10 and x plus 4. And my bottom factors into x plus 4. It's coming from here, x plus 4 times x minus 4. Now I cancel out the common factors between the top and the bottom. Whatever looks the same, basically. X plus 4 on the top, x plus 4 on the bottom gives me just x plus 10 left on the top and x minus 4 left on the bottom. That is as simple as that is. You cancel out the common factors after factoring both the top and the bottoms. Just wanted to point out one more thing, especially comparing these two types of problems. When you have just x's in a problem, like that, there's only one variable there, use factoring by grouping, or the case 1 where just a equals 1 and you're just looking for numbers that multiply to be c and add up to be b. You're just looking for two factors split into groups like this. When we have two variables, or 3 or 4, or however many, when we have more than one variable, then you're looking for the GCF, or at least a common factor. It doesn't necessarily need to be the greatest common factor, but it should be a common factor between all of the variables. You're looking for something that divides this, something that divides that. It's not that easy to divide it just by that term by itself. We can think about a monomial that will divide this and this, which happens to actually be our answer. The thing that divides both of these is the greatest common factor, because what we're left with cancels this out. So when we have more than one variable, use a GCF. When you have just one variable, you're factoring into two groups like this. Sometimes it's factoring by grouping. Sometimes it's just looking for what multiplies to be A and C. Sorry, B. Excuse me. What multiplies to be C and adds up to be the middle term, or B. I'm going to do one more problem in this video, and that's letter E in the U try. Just because of the way it's formatted, I think we know how to do the math behind it if we understand what the problem's actually asking. It's saying the volume of a cone is represented by the equation V equals 1/3 pi r squared h. The volume of a specific cone is this. That means that is the volume, that's the answer. When we multiply all of this stuff out. And it's saying in the next step that this is equal to that. 1/3 pi r squared. That entire multiplication problem is the same thing as this entire multiplication problem. So I'm going to use a property that we learned about before called substitution. I'm going to basically just get rid of that 1/3 pi r squared in this and replace it with something that's equal to it. 7xy squared. And I'm going to keep the h attached to that. That's still being multiplied times h. The h comes down, and really, technically, this comes down too, but it just is represented in a different way. It's represented with something that's equal to it, which is that 7xy squared. Now I have a multiplication problem that I want to solve. I have an equation where I want to cancel out some multiplication. I'm going to use the opposite operation, which is division. I'm going to divide by 7xy squared. Cancel this out. If I divide on that side by something, I have to do the exact same thing on this side. Divide by 7xy squared. Now I can use my division steps. I'm going to simplify each of those fractions separately. That gives me 3y to the first minus 10xy plus 1. I'm subtracting exponents, I'm canceling out those x's, and I'm dividing the coefficients. Subtracting the exponents, dividing coefficients. And these actually all just cancel out. 7 divided by 7 is just 1. Those cancel out, those cancel out. That just leaves me with a coefficient of 1. So my height of the cone is that entire expression.